Previous lecture you saw a video about how sample proportions turns out to be a distribution, and we briefly discussed about how if the number of sample proportion is very large, then it turns out to be a normal distribution. Okay, so that's it. Now let us take an example for this sample proportion distribution. And before that, I will just want to recall this few notes that you might want to remember. So the shape of the sampling distribution p hat is approximately normal if np times 1 minus p is greater than or equals to 10. So this value n times p times 1 minus p is basically the binomial distribution, right? Since n is the total number of samples, right? And p is the probability of success, and 1 minus p is the probability of the failure. Okay, so then now once you start to gather a lot of many samples, and then the mean of those proportion would be simply p. Okay, so that's what we had for binomial distribution, right? And similarly, the standard deviation is slightly different. Okay, sigma p hat is square root of p times q, where this q is the failure, right, divided by n. Okay, so that's it. And the z score is this one. This is the x value minus mean divided by the standard deviation, and standard deviation is root under p times q divided by n. Okay, so that's it. Now let us head over towards one of the examples that we would like to look onto. Okay, so let us go for this one. Here it is saying that according to credit.com, 29% of adults do not own credit cards. So the proportion p is simply 0.29. all right, and if you go for question A, suppose random sample of 500 adults is asked, do you own a credit card? Describe the sampling distribution of p hat. Okay, so that would be n equals to 500. Okay, so that's for A. Mu p hat is simply 0.29. okay, so that's it. And by describing the sample distribution, we just need to understand what is the mean and what is the standard deviation. So mean is already there, we have already found it out. Now for the standard deviation, sigma p hat equals to p times q, p minus 1 minus p, divided by 500, right? So that's n. Okay, so if you take a look at the formula that we had previously in here, then that's over here. Right, so that looks good. So let us work this out, and yeah, so this is basically root under p is 0.29 times 1 minus p is 0.71, right? Yeah, 0.79 divided by 500, right? Okay, so let us pull out our calculator and work that. 0.29 times am I correct? 1 minus 29 is, yes, if it were 30 then that would be 70. Okay, so that's fine. 0.29 times 0.71 divided by 500 equals to this much. Okay, and let's take square root of this one. Okay, if we take square root of this one, then that would be 0.02029. okay, we can write this thing as 0.0203. okay, so that would be equals to 0.0203. so that's our standard deviation. Okay, so mean is found out, standard deviation is found out. So it's approximately normal distribution whose mean is 0.29 and whose standard deviation is this one. Okay, so let us mark this out. Okay, we will be needing this thing over and over again. Okay, since this distribution is approximately normal, I would want all of us to go towards this this website, geogebra.org/classic/probability, and you'll be getting this nice figure. This is standard normal distribution. However, we already know that our mu, the mean is 0.29, so let us write that down, and our standard deviation is 0.02 0 to 9. Yeah, let us write that down, or yeah, 2928. 2928. Okay, that's fine. Now I just wanted to write this thing down so that it will be much more easier for us to calculate at a later time, okay, for other problems. So let us go move on. So A is done. Now let's go for B. Okay, so that's for A. For B, okay, for B it is saying that what is the probability that in a random sample of 500 adults, okay, here still this is 500, okay, so that's the same thing over here. More than 30% do not own a credit card. So probability of getting this proportion sample is greater than 0.30. Okay, since this is the kind of problem where we have two things, okay, either success or failure, right? Success in this case is getting an adult who do not own a credit card. So basically this question B is asking about what is the probability of success that 30% of the people do not own a credit card. So let us go for that. So this is quite easy to realize, and we know that we need to figure out probability of this proportion sample greater than 0.30, and the sample are 500, okay, still unchanged. So let us head over there, and we know that we need everything beyond this 0.3. okay, so I would choose this one, the right-sided distribution, and let me go for 0.3. okay, 0.3111. 0.3111. okay, so that's the probability that 30% of the people will not have a credit card, won't have a credit card. Okay, so that, let us move on for C. What is the probability that in a random sample of 500 adults, between 25% and 30% do not own a credit card? Okay, so basically here also we'll do the similar kind of thing. Okay, so C, it is simply saying between 25% and 30%, okay, do not own a credit card. So basically this is probability of 25% means 0.25, right, is less than P hat, that's the proportion distribution, 0.3. okay, we would go for this one. All right, now it's quite easy to plug in all of these things over there. Again, let's go to the same website and choose this one, since we want something in between two values. Okay, so let's go for this interval distribution. Okay, so that would be 0.25 and this would be 0.3. okay, so that's fine. So that would be 0.6646. so that is 0.6646 to be the probability. Now let's go for the last one. Would it be unusual for a random sample of 500 adults to result in 125 or fewer who do not own a credit card? Now here the proportion is not given, instead the number is given. Okay, so the x value is given. So I would simply, so D, x is given to be 125. Okay, so you can realize that the total number n is 500, right? It's still 500. Yeah, suppose over here is 125, then we would like to find out this thing, okay, this shaded portion of the area. So first of all, we need to figure out the proportion, okay, the probability of the success. Okay, so which is simply x over 500. Okay, x over n. That's how the proportion, sample proportion distributions are created, right? 125 over 500. So which is 125 over 500 is 0.25. Okay, 0.25. All right. So it is saying that 125 or fewer owning a credit card. Okay. Okay, here we can see that this P is 0.25. So that's the proportion, and proportion is 0.25, and everything is same. Okay, nothing has been changed in this situation. We just want to figure out the probability of this probability of sample being less than 0.25. Okay, so that's and which represents that 125 or less people will be using do not want the credit card. Okay, so that's it. So let us head over to the same website, GeoGebra, and plug it. This would be we would go for this right-sided distribution, left-sided distribution. Okay, and this is 0.25. all right, so that's it. So if we go for that, then that we'll be getting 0.0244. okay, 0.0244, 0.0244. So we got the probability, but however the question is asking, would it be unusual for a random sample of 500 adults to result in 125 or fewer who do not own a credit card? It will be unusual if the probability is less than 5%. okay, so here you can see that this is 0.0244, means that's nearly 2.44% unusual, since the probability of 125 probability of 125 out of 500 people using credit card, using no credit cards is less than 0.25. okay, less than this kind of proportion. So this is quite unusual, right? Since usually it is saying that 29% of the adults do not own a credit card. So okay, all right, so this is it. Okay, thank you so much.